Imagine writing a Python program with 5,000 or even 50,000 lines of code in a single file. Would it be easy to find a function? Would it be easy to fix a bug? Would it be easy to work with a team? Absolutely not. Professional programmers don't write everything in one file. They divide their code into smaller organized files called modules. Today we will learn what modules are, why they are important, and how they make programming easier. Now, what is a module? A module is a Python file which is represented by .py that contains code such as functions, variables or classes which can be reused in other Python programs. Think of module as a toolbox. Instead of carrying every tool in our hand, we keep them inside a toolbox. Whenever we need a tool, we open the toolbox and use it. Similarly, instead of writing all your code in one file, we keep related code inside modules. For example, I have a school bag, and in the school bag I have different books. I have maths book, English book, science book. Every subject has its own book. Imagine if all the subjects were printed inside one huge book. It would be difficult to study. Modules organize code in exactly the same way. Now, why do we need modules? Without modules, everything is mixed together. Finding one function becomes difficult, updating the program becomes harder, and teamwork becomes confusing. But with modules, every file has a specific responsibility. The project becomes clean, organized, and easy to manage. So the very first advantage of using a module is code reusability. That means we use it, we write the code once and we use it in many different programs. Use code again. If you have already built a calculator module, you can use it in your next project without rewriting it again. The second advantage is better organization. An organized room is easier to manage. Similarly, organized code is easier to understand. Next advantage is easy maintenance. If a bug exists in one module, you can fix only that file. You don't need to search through the entire project. Next is team collaboration. Different team members can work on different modules at the same time. Next is less repetition. Modules help us avoid writing the same code again and again. Imagine in a kitchen, every item has its own place. Imagine if everything were thrown into one big box, finding anything would take a long time. Modules keep our code organized in the same way. Now Python have mainly two types of modules. We have two types of modules. The first one is built-in modules. Built-in modules are already provided by Python. We don't have to create them. These are already provided. For example, we have a math module, we have random module, we have datetime module, we have OS module, and we have statistic module. Other type is user defined modules. These modules are created by programmers. You write your own Python file and use it in other programs. For example, I create a calculator module and name it calculator.py. I can create a student module, we will name it student.py. We can create a bank module and name it bank.py. In this way we can create our own modules. For example, in mobile apps, every app performs a different job. Together they make your phone useful. Modules work in similar way inside a software project. Now when should we create a module? We should create a new module when file becomes too large, the task can be separated logically, the same code is needed in multiple projects, and you want better readability. So now we understand what modules are and why they are essential in professional programming. In the next section, we will learn how to use modules in Python. We will discover different ways to import modules using the import statement. In the previous section, we learned what modules are and why they help us organize our programs. But knowing that modules exist isn't enough. We also need to know how to use them. Imagine there's a library full of books. Before you can read a book, you first need to take it out from the shelf. Similarly, before we can use a module, we need to import it in our program. Now, what is importing? Importing means bringing a module into your current Python program so that you can use its functions, variables, and classes. A module may already contain useful code. Instead of rewriting the code, we simply import the module and use it. For example, in a library, there are thousands of books, and we went there and we choose one book and read it. The library contains many books. You don't carry the entire library, you choose only the one book you need. Importing works the same way. Now, how to write the import statement? For the import statement, firstly we write import and then module name. The import keyword tells Python, name this module available in my program. For example, I want to import an entire math module. So what will I do? I will write import math. When we import the entire module, all its contents become available through the module's name. We can also import the specific function of any module. For that, we write import say from the module, this module I want to import a function. So I will write from module, we will define the module name which we imported, import, then the name of the function which we want to import from the particular module. Sometimes we only need one or two functions. Instead of importing the whole module, we import only the required function. We can also import multiple functions. For that, we write in a similar manner, module name, import function 1 and function, function 2. Python also allows importing multiple functions together. Now, what is the use of alias? Sometimes module names are very long. Python lets us create a shorter name called an alias. For that, we will write import module name as alias. Take it as a nickname. Now, if I want to import everything from a module, for importing everything, for that we write from module name import star. This imports everything from the module. While it works, it's generally not recommended because it can make code harder to understand and may create name conflicts. Now we learned about different import methods. Now, whenever we create our own modules, there are some rules which we have to follow. These rules are called module naming rules. Firstly, we have to choose good modules name. We can create modules and name them as, say I create a calculator module. For that I will write calculator.py. For a student module I will write student.py. This is how we should choose names. Avoid these kind of names like my/file.py, 123.py. Avoid using these kind of names. Modules names should be meaningful. Use lowercase letters when possible and avoid spaces and special characters. Now, how Python finds a module? When Python sees an import statement, it searches for the module, and if it finds the module, it loads it. If not, it raises an error. Now, there are some common import errors while importing a module. The very first error which we find is module not found. If the module doesn't exist or Python can't find it, you will get module found error. Then we have wrong module name. Wrong name. Module names are important. Spelling mistake means Python won't find the module. Then we have wrong function names. Even if the module exists, trying to import a function that doesn't exist will produce an error. And the last is naming file like built-in method. If we name the file same as the built-in module, if you create your own file with the same name as the built-in module, Python may import your file instead of the built-in one. This is a very common beginner mistake. Now we understand the different ways to import modules and why each method exists. In the next session, we will explore some of the Python's most useful built-in modules, including math, random, datetime, OS, and statistics. In the previous section, we learned how to import modules, but what modules does Python actually provide? Imagine buying a new smartphone. It already comes with apps like camera, calculator, calendar, clock, and gallery. You don't need to create these apps yourself. Python works the same way. It comes with many built-in modules that already are ready to use. Today, we will explore some of the most useful built-in modules that every Python programmer should know. Now, what are built-in modules? Built-in modules are modules that are already included with Python. We can import and use them without installing anything. Python developers have already written these modules. Instead of writing common tasks from scratch, we simply import and use them. For example, we have a new smartphone. In the smartphone, we have apps like camera, calculator, clock, calendar, and gallery. These apps are already available when we buy the phone. Similarly, Python provides many useful modules by default. Now we will quickly look at some popular built-in modules in Python. The very first module is called math module. Math module is used for mathematical calculations. In math module, we have functions like square root, we have power, factorial, trigonometry, and pi. Imagine you are creating a calculator, a scientific calculator, a game, or a data science project. All of these need mathematical calculation. So instead of writing complicated formulas yourself, Python's math module already provides them. After math, we have random module. The random module is used to generate random values. Example, random modules contain random numbers, random choices, and random lists. Random values are used in dice games, card games, password generation, lottery systems. Every time you roll a dice, you expect a random result. The random modules helps us do exactly the same. After random, we have the datetime module. The datetime module is used to work with dates and time. This works with date and time. For example, I want to fetch today's date, current time, day, month or year. In real life examples, this module is used in attendance system, banking software, social media posts, online shopping orders and hospital management system. After datetime module, we have OS module. The OS module is used to interact with different operating systems. OS module contains folders, files, dictionary, and system information. This module helps Python communicate with your computer's operating system. It can access folders, create dictionaries, rename files, delete files, or check the current working dictionary. After OS, we have statistics module. Statistic module is used for statistical calculations. For example, we want to calculate mean, median, mode or standard deviation. In that cases, this module is used. Now, why built-in modules are popular? Without built-in modules, we have to do everything manually. But with built-in modules, we can import module, and those imported modules are ready to use. Now we know some of Python's most useful built-in modules and what they are used for. But what if you create your own useful functions and want to reuse them in multiple projects? In the next section, we will learn about user-defined modules. In the previous section, we learned built-in modules like math, random, and datetime. These modules were created by Python developers. But here's an interesting question. Can we create our own modules? The answer is yes. One of the Python's greatest strengths is that it allows programmers to create their own reusable modules. Today, we will understand what user-defined modules are. User-defined module is a Python file created by the programmer that contains reusable code such as functions, variables or classes. Instead of writing the same code again and again, we place it inside a separate Python file. Whenever we need that code, we simply import the module. Imagine you are a carpenter. Over time, you collect your favorite tools in your own toolbox. Whenever you work on a new project, you use the same toolbox. A user-defined module is like your personal toolbox of code. Now, why do we create user-defined modules? What is the need to make these modules? First is code reusability. We can create our own code and we can reuse the code again and again. Then we have better organization. We can create our Python files in more organized manner, which makes it easy to access. After that, easy maintenance. If there is a mistake in the module, you can update that module. Every project using the module automatically benefits from the updated version. And last is faster development. Faster development. Instead of rewriting common functions, simply import your existing module. Now, what can a module contain? A module isn't limited to function. It can also contain variables, constant, and later in the course, you will learn that it can contain classes as well. For example, we have a school department. In the school, we have mathematics department, we have teachers, and in the mathematics department, we have teachers. Teachers have books, and books are used in classrooms. One department contains many related sources. Similarly, one module contains related pieces of code. For example, I am making a project called Student Management System. This is my project name. And in this project, I will create different type of modules. The first module which I will have is student.py. Then we have marks.py. After that we have attendance.py. Then we have fees.py. And then we have main.py. Instead of writing everything inside one file, each task gets its own module. Now, how does a user-defined module work? The process is very simple. Firstly, we create the Python file. We create Python file. Then we write functions. Then we save file. Then we import module. And then we use it. The process is very simple. Create a file, write reusable code, save it and import it wherever you want. Now, where are user-defined modules used? These are used in banking softwares, hospital management systems, school management system, e-commerce website, mobile applications, and data science projects. Now, what is the difference between a built-in module and a user-defined module? Built-in versus user-defined. See, in built-in modules are created by Python. And user-defined modules are created by the program. These are already available. And these modules, user-defined modules, must be created. These are used for general purpose. And these are project specific. So now we understand how programmers create their own reusable modules and organize large projects into multiple files. In the final theory section of this lecture, we will learn about packages, and you will understand how multiple related modules are grouped together inside one package. So far we have learned that a module is simply a Python file containing reusable code. But imagine you are working on a very large project with 100 or even 500 modules. Can we still keep all those files in one folder. It would quickly become difficult to manage. That's why Python provides packages. A package helps us organize multiple related modules into one folder. A package is a folder that contains one or more related Python modules. Think of package as a folder. Inside the folder, we keep multiple Python files that are related to each other. For example, a library contains different sections. Each section contains related books. Similarly, a package contains related modules. Now, what is the difference between a module and a package? A module contains a single Python file, while a package contains folder containing modules. This ends with py, and this contains multiple py files. Holds reusable code. And this organizes related modules. Module is a smaller unit and a package is a larger unit. We can say a module is a one book and package is a bookshelf containing many books. Now, why do we need packages? Packages provides better organization, instead of hundreds of files in one folder, we divide them into meaningful groups. Easy navigation, and team collaboration. Now we will look at what is init.py. Traditionally, Python packages often include a special file called init.py. It tells Python that the folder should be treated as a package and it can also contain package initialization code. In modern Python, this file is optional for many packages because Python supports namespace package. However, you will still see init.py in many real-world projects, so it's good to know what it is. Now we have successfully completed the theory section of this lecture 9. We learned what modules are, why modules are important, different ways to import modules, Python's built-in modules, user-defined modules, packages, and how they organize large projects. These concepts are used in almost every professional Python project. As your programs become larger, modules and packages will help you keep your code clean, reusable, and easy to maintain. In the next session, we will move to Jupyter Notebook and we will learn how to use these built-in modules like math, random, datetime, and OS. Welcome back everyone. In the theory session, we learned what modules are and why they are useful. Now it's time to use them practically. We will start with two Python most commonly used built-in method modules. First one is the math module and second one is the random module. Now, in the very first program, we are going to import our module. Here I'm going to import the math module. So I write import math.
Now import is a keyword and math is the module name. Now we are going to use this math module. Say I have a number equals to 81 and I want to find the square root of this number. For that I will create a variable named result and the variable I will write math, which is our module name, dot the function name which we are going to form, that is square root function. Square root number. We are going to print the result. So the square root of 81 is 9. Square root means square root and sqrt means square root and math dot square root 81 returns 9. Now in the next function we are going to use pi method. So if I write value of pi is, which is equals to math dot pi. So this gives me the value of pi, which is 3.1415. After that we have the power function. If I write print math dot power 5 comma 2. 5 comma 2 means square of 5, which is 25. If I write print math dot power 2 comma 8, which is 2 to the power 8, which is 256. After that we have the factorial function. For that we will write math dot factorial. Say I want to check the factorial of 5, which is 120. Then we have the seal and floor method. If I write print math dot seal. So what seal function do? Seal function round off the value to the next positive number. The next positive number after 8.2 is 9. So it will return 5. Then after seal we have floor method. Floor method is exactly opposite of seal method. What does floor method do? It round off the number to the lowest positive value. Here, the lowest natural number uh, close to 8.9 is 8. So it prints 8. Seal always rounds up and floor always round down. Now, what we will do, we will try to import only one function. Say I want to import only square root. For that, I will write from math import square root. In this manner, we can obtain any one function or any number of functions we want from our module. Instead of importing the entire module, we can import only the square root function. Now we are writing this math again and again, math.floor, math.seal. What if I don't want to write math? That's where we use an alias. If I write import math as m. So now I don't need to write math.floor, math.seal. Instead of this, say I copy paste this. Now I don't need to use the math. I can only write m.factorial. This will give me the same result. Now we have understood how math module works. Now we will move to the next module, which is random. For that, I will write import random. So what will random function do? If I want to print, say I write random dot rand int. So randint means random integer, and I will provide it a range. Say I want a random integer from 1 to 100, so it will give me 89. It gave me 89. Now, if I again copy paste and run this function, now it will give me another number. So the random functions randomly picks the integer between 1 to 100 and it will give me that output. And each and every time I run the code, output will be different. We can also use it with variables. Say I create a list for languages, and in this list, I will write different languages. Say I write Python, Java, C, and JavaScript. So I created languages variable and a list of languages. Now I want to print any random value from these stored languages. For that, I will print random dot choice languages. Choice selects one random item from the list. Now it gave me C. If I copy paste and again run this, now it gave me JavaScript. So how this is how random dot choice works. We can also shuffle the numbers in list. Say I create a list of numbers, and if I write random dot shuffle numbers, and then I will print the numbers. So you can see the order changes every time. The order will change every time I run this program. See if I use again print number, if I copy paste this again, then print. Now it give me a different order. One more time. So every time I will run this program, it will give me a different order of numbers. Now let's make a mini project. This project is called dice roller. So what we are going to do, we are going to use the random function and we will show the outputs of a dice. Say I create a variable called dice and in this value I will show random dot rand int and the values of dice can be vary from 1 to 6 and then I will write print dice shows dice. So now dice shows 6. If I again run this, it will give me a different number. After this dice function, we have pointers. Say create a variable named coin. We are going to make a choice between heads and tails. Let random dot choice. Choice will be between heads and tails. In this, I will pass the list in which I will store heads and tails. And I will print the result. Print result. See, it gave heads. So now we learned how to import modules and use the math module for calculations and random module for generating random values and building simple games. In the next session, we will explore the datetime and OS modules. Previously, we learned how to use math and random values. Now we will learn two more important built-in modules. The datetime module, which helps us work with dates and time, and OS, which allows Python to interact with your computer's operating system. Firstly, we will import the datetime module. Let import date time. Say I want to check the current date and time now. For that, I will create a variable called current, and in this I will write date time dot datetime dot now. And if I print current, it will give me the today's date and time. datetime.now returns the current date and time. The exact output depends on your system's clock. Now, if I only want to display today's date, for that, let's create another variable called today. And in this, I will write datetime dot date dot today. And, and if I print this value, it will give me today's date. Now, in the next program, we will display individual parts. We will display the year, month, hour, minute, and seconds differently. Say I'll create a variable called now. This I will say date time dot date time dot now. And now we will print the individual values. How we will do that? Firstly, we will write print statement. Say I want to print the year. I will write year is equals to now dot year. Similar way we can print all other values. If I want to print the day, firstly we will print the month equals to now dot month, then day. We can print many other values. We can print, say if I print here day, after that I will write hour. We can print the hours also, and then we will print minutes, and lastly we will print the seconds. Here you can see it prints year, month, day, hour, minute, and second differently. Now we can also change the format of date. In the default format, we have year first, then month, and then date. But what if I want to print date, month, and year? For that, what we will do, I will use this variable again. Say I want to print formatted date, so I will create a variable named formatted. This variable I will write new dot strf time. Strf time formats the date, and after that we will write the format. So I want first date, then month, and then year. For that we will write %d. After that I want percent month. After that year, which is %y. Then I will print format. So it prints 28 7 26. If I use capital letters here instead of this small d, small m, and small y, so it will print the complete date, which is 07/28/26/2026. And if I want in the different manner, we'll simply write 28/7/2026. The %d means day, %m means month. If I write %capital Y, it will print the whole year. Say now 2026 is going on. If I write capital Y, it will print 2026. If I write small y, it will print 26 only. %h is used for hours, %m for minutes, and %s for seconds. Say I want to print the current time also. For that I will write now dot strf time that I will write the time format. Firstly, I want the hours, that I will write percent H, then I want minutes, percent M, and then I want seconds, percent S. So it will print the time, which is 20 hours, 26 minutes, and 31 seconds. Now let's move to the another module which we're going to do, which is OS module, operating system module. Say I For that we will first import the module. I will write import.os. Let's say I want to check the current working directory. For that I will write print os dot get cwd. So get cwd means get current working directory. It shows the folder where the Python program is currently running. So this is my folder in which I am running this Jupyter notebook. We can also use it to create a folder. Say I write os dot mkdir, my folder. Create a folder name my folder. So mkdir creates a new folder. So now a folder called my folder is automatically generated in my memory. Now if I want to rename this folder, I can also do that using the rename function. For that I will write os.rename. Firstly, we will write the current folder name, which is my folder. And after that, after comma, we will write the new folder name. Say my folder name is Python folder. Now the folder is renamed from my folder to Python folder. Now what if I want to delete this Python folder? For that, I will write os.rmdir. So the rmdir removes an empty folder. That I will write my folder name, which is Python folder. So now it will delete the folder. So this was all about datetime and OS modules. These modules are used extensively in automation scripts, attendance system, logging application, and file management tools. In the next upcoming topic, we will learn how to create our own self-defined modules, and we will import them into our other Python files. Now we have studied Python built-in modules like math, random, and datetime. But what if we want to create our own module? The good news is that Python allows us to create our own reusable modules. Since we are using Jupyter Notebook, we will first create a Python file and then import it into our notebook. We will go to home and we'll create a new text file. And we will save this file name as calculator.py. And now we will open this file. This will give me a Python file. Then we will write our code in this Python file and we will import it to our main notebook. Now we will define our calculator. So a calculator can add, subtract, multiply, and divide. First, we will create def add, a function for addition, which will return a plus b. Def subtract, this will return a minus b. Def multiply, a comma b, this will return a star. And def divide, a comma b, which will return a divided by b. Now we will save this file, and in our main file we will write import calculator. Now we made our own Python module which contains a reusable functions. Now here no error appears, which means our module has successfully imported. Now we will use these the functions which we created in the calculator module. Say I want to print addition of two numbers. For that I will write calculator dot add 10 comma 55, which will give me 15. If I write print calculator dot divide 10 comma 2, this will give me 5. Or say I write print calculator dot multiply 2 comma 2, this will give me 4. So the calculator is the module name, and this addition, divide, and multiply subtraction was the function inside the module. Now what if I want to import a specific function? Say I want to import subtraction. For that I will write from calculator import subtract, and now we can use that function. I will simply write subtract dot 50 comma 20, that is 30. We can also import multiple functions. Say I write import subtract comma addition also, and if I copy paste, and if I change this subtract to add, this will give me 70, which is 50 plus 20. Now similarly we will create another file here, which is student module. We will create a student module, new file. We'll change the name to student.py. We will open this student.py, and we will create a function to show details. Def details, we will store name, age. This will print name, which is name, and age, that is age. Control S. We will save this module, and now we will import this. Let import student. Now if I want to print student dot details, I will pass the name, which is Rahul, age which is 21. So this will print name Rahul, age 21. Now we will create another module which is called geometry module, in which we will write the logic to find the area of square and rectangle respectively. First we will create new file. We will name it geometry.py. We will open this file, and we will write our code, which is def. First function is square, side, return, which will return the area, which is side multiplied by side, then def rectangle, which will take length and width as parameters, and it will return area, which is length multiplied by width. We will save this and we will import it. Let import geometry. Now, if I want to print the area of a rectangle square whose side is 5 centimeters, for that I will write print. Actually, we will import geometry as G. Now we will use this. We write G dot square whose side is 5 and the area is 25. Similarly, we will print the area of a rectangle G dot rectangle whose length is 5 and width is 2, which is 10. So now we learned how to create our own Python modules and use them in the Jupyter notebook. We also learned how to import entire modules, import specific functions, use aliases, and reload modules after making changes. These techniques are used in real-world Python projects to keep code clean, organized, and reusable. In the final lecture of this Python programming series, we will learn about file handling.